First of all, I'd like to say thank you to John Paul and John and Nicola for organizing this wonderful meeting. And I really envy all of you organizing this very stimulating workshop here in Toulouse. My talk today is very primitive one, as usual. I'm always talking the primitive works and never matured. But my talk today is about the NOH, and this is one of the very traditional culture of Japan. And I will explain what I learned recently. And I'm not a cultural man like John Paul. I'm mostly the engineer, and I think 90% of myself is probably a curiosity-driven person, but 10% I'm a craftsman or engineer, and I want to use our development for some useful purposes. And this is some initial effort that we are trying to do something useful. Well, by the way, this is the poster of our graduate school, School of Information Science and Technology, last year and this year. And this poster, fortunately, got the 2 medals, thanks to the designers, and also thanks to the collaborators. I was involved in making this poster, and the collaborator was the professional NOH player, and we started the collaboration being involved in this poster. About the Japanese dance performance, I have 3 slides of the total history, so it's very short. So Gigaku is probably the very initial dancing performance introduced from Korea, and of course from China. It's controversial. Maybe it is said to come from the India or Persia or from the Silk Road, and it was in 7th century. And when the big Buddha in Nara was established in 752, there was the performance of Gigaku. It was the 752. And it soon disappeared, but only the music part is still remained at the Gagaku. Gagaku means noble music. And Sangaku, that is another dance performance arrived from, again, Korea, 8th century, Heian era. And the Gagaku and the Sangaku were under the protection of the emperor. So it was quite nicely taken care of at that time. But in the 9th century, the emperor's protection finished, and then the dance became the people's dancing. And Sarugaku is that kind of dance performance started from 9th century. And in the 14th century, the famous father and son established a particular style of Sarugaku. That is later in Meiji era named as NOH. So NOH was established in 14th century, but named very recently. So in the 17th century, the Kabuki started, and this is the 19th century, the ukiyo-e of Toyokuni. This is, of course, a theater in Tokyo at Edo in that time. And it was very popular, but the kabuki originally started as a women performance, but later it's being played by only male actors, and now played only by male actors. Well, the kan-ami and zeami, they are the father and son in the 14th century. And zeami wrote a textbook, which is still the most important textbook. And there are many famous phrases. And I recently purchased a book and starting reading this. So, but the one of the famous phrases that the Deami said in Japanese, "Hisureba hananari, hisezuba hana naru bekarazu." That means if it is hidden, it is a flower. If it is not hidden, it is not the flower. The name of the book, Fushikaden, in Japanese means that wind shape, flower, express, something like that. So anyway, this is the most important book. And the after reading some information in the books or maybe Wikipedia, I realized that the no tend to express the minimum movement. And they use the mask expression. They wear a mask, and they only control mask very minimum way. My friend performer said plus 5 degrees or minus 5 degrees. We measured, and actually it's more than that, but they say very, very slight inclination is important. And it is also very important, no play is always comes after no text. Text comes first, and no play comes later. And this is probably most well-known and one of the probably one of the two most popular historical person in Japan. He's Oda Nobunaga, and he first introduced guns in battlefield, and he was almost conquered whole Japan when he was killed. And he himself enjoyed and he played no performance. And the playing no performance seems to be very noble hobby for those high level the samurai or the noble people. So that's why the very different from the kabuki. It's to be very noble, and people try to sophisticate the style of no. And some information said they used to have more than 2,000 plays, but now it remains only 200 something plays. So these are the school of no: Kanze school, Hojo school, Kompal school, Kongo school, Kita school. Actually, Kanze school is a family of those father and son. It still continues. Actually, I think I read something like the daughter of Zeami married with family of the Sen no Rikyu, who is the person who studied tea ceremony. So tea ceremony and no in style very close. And my friend Keisuke Shiozu, he's a professional no player, is the member of Shio's family, and that is the 5 families in Kita school. So maybe this is too dark, but this is the typical no theater. And sometimes no theater is in the outside. if you have had chance to go to the Miyajima, Miyajima has no theater on the ocean. And that is a very unique place. And this is the theater of the Shio's family, and they have the theater at home. And the theater is being observed by the audience from 3 sides. So it's square, small square, but observed from 3 sides. I found one of the Shio's, my friends that play in the YouTube. This is about the samurai who died at 16 years old at the war between 2 families. I don't know if I have. Sun. Is very simple, and a couple months ago myself and my friend had a workshop, and the title was "If Robot Can Play No." But looking at simplicity principle, maybe it is possible, and my position is, of course, yes, robot can, but of course he said no, robot cannot. Okay, so here is our questions. We wonder if our technology has accuracy to analyze dance performance. So we have some technology we have been developing so far, and I want to use it for helping or doing some analysis of real dance performance, or maybe athletic movement. These are something we are challenging right now. And second, we also wonder if we explain dance performance using our technology. So it is always very difficult to explain physical activities like martial art or sports. There are no scientific words to help training, or it is always very difficult. So again, it's very challenging, but that is a second curiosity. Third, of course, we may find technologies that makes scientific contribution possible in dance performance. If science can contribute to the real performing art, that will be very fantastic. And I don't know if we can find something like that, but that's a question. Well, more specifically, we are doing and asking this, can we mathematically identify the minimalism of the no performance? The no performance said to be very simple, and the movement is minimized. So if our analysis can explain this. The second, can we explain the skew of no actors behind the minimalism? What kind of the body skills are there for this minimalism? And of course, number 3 is something we recently realized when we were looking at their data. Can we model the improvisation of the actors and musicians? Actually, I will show the video and data, but the actor and the musicians are playing each other, not by looking at each other. And there's no coordinated scores. And each of them, of course, trains themselves at home. But very rarely they train together. They gather one time and coordinate instantly. So it's like the jam session of jazz music. And it's quite exciting to see how they do. And the question is, what is that? And if we can investigate and find some mystery inside that kind of interactions. But in reality, what we are measuring and comparing is very simple and primitive, and you may be bored. Maybe I should explain first. I prepared appendix of my talk, but our technology that we have robotics technology to model the rigid body movement and analyze the kinematics dynamics and compute the forces between the bones. And by using motion capture data, we recover the bone movement and we compute the forces acting on the bone, assuming all the masses are concentrated in the bones. And then we estimate by using the least square type of optimization, the tension of muscles. So we can visualize the tension of nearly 1,000 muscles almost in real time, 30 cycles per second. And we are superimposing. Actually, this nice picture is created afterwards. But we can superimpose the muscle activities in real time. The critical problem is that because of the motion capturing, some markers are lost. Then it is quite difficult to track the data afterwards. So in that case, we have to retouch the data afterwards. So as for the computation, we can compute and estimate the muscle activity in real time. I know you are bored, and I used to be bored when I was a high school pupil and going to no play, and we can't understand the text at all. So it's very slow, and the movement is simple. And it is probably fortunate, very fortunate for us that he is helping us. Otherwise, it's impossible to measure those kind of movement and using the EMG and the markers. And Professor Hachimura has a lot of data of motion captured from no players or other people, but the data is a secret. I mean, not secret, but they cannot provide anyone else. It's very, variable data, and probably it's hard to analyze the muscle activities. So we are very happy that he's helping us. So you might notice that maybe I should. So please look at the movement of, okay. Okay, so look at the movement of pelvis. The pelvis movement is very unique. And we first look at the movement of pelvis and measured. I guess it is more clear. Sorry. So normally they have to control the eyesight horizontally, and only when they are a little happy they raise 5 degrees, and if unhappy they lay down the 5 degrees, something like that. Well, we compare the effect of pelvis movement. Actually, the pelvis was moving pitch motion, and it's very unique. So we made some simulations. In the bottom case, we completely control the pelvis to be straight upward. And this is the original capture data. This is the compensated data. Of course, other movement is same. Okay. So this is the pitch motion pelvis. So this is from time 95 seconds to 105 seconds. It's for 10 seconds. And he's making 3 or 4 steps. And you can see the pelvis are quite typically rotated and making pitch motions. One pitch motion in one step. And this is a comparison. The red one is the computed top head position from the measured data. And the green one is the movement of the head motions computed from the stabilized pelvis data. So the difference is very small. Difference is very small. I cannot show the markers. Laser?
Yeah, there is a laser.
Ah, thank you.
This one.
Okay, thank you. So please look at this point. The red one is the one controlling the pelvis, I mean the original data. And green one is the case with stabilized pelvis motion, no pitch motion. So if he didn't control the pelvis pitch motion, he probably had very sharp movement of the head, like this, and like this. But of course, the height of the head has more larger change in the case of controlling the pelvis. I mean, controlling the pitch angle of pelvis. So maybe we can explain that by using pelvis motion, he's stabilizing the head. He's protecting from the rapid head motions. So this is something we can easily observe from his motions. And let me show the recent result. This is the one of the performance of his father. I think his father. working. It was? Oh, yeah, yeah. It's minimum. This is important part. On the bottom of the stage, there's a big pottery, and that helps making good sound. So making good sound is very important. Maybe this is too long. So the actor is wearing the mask, and the mask has very small eye hole, so he cannot see many, many places. Yeah, this is very important part. This is the bell, and this scene is the famous scene of Dojoji. Dojoji is the name of the temple, and this story is that a priest was loved by a girl. She is a girl, and because he is a priest, he cannot accept the love from her. But she followed him, and she couldn't give up. And actually, finally, she entered the bell. And when she comes out, her shape was a snake, something like that. So it's very famous old story, and this story is seen both in Kabuki and the NOH. So it's a famous story. So this is after entering the bell. This mask is called Hanya. Hanya is very scary for children, but this is the mask of a woman, and with some anger or some jealous, or so very, very scary mask. So we captured several data with the help of the NOH actor Shiozu Keisuke, and also 3 musicians came to our capture lab: the large hand drum, and small hand drum, and flute. And we used the optical markers, wireless EMG, force plate, and we also measured the musicians at the same time with 4 EMG each, and the voice mic and instrument mic. And this is a name. Actually, the flute person is anonymous because he is a person he's supposed not to be here. I don't know the reason, but he said. So the nose screw is very complicated. So this dance is called otokomai. Otokomai. That means men's dance, but this is also part of dojoji, the same story. And three musicians and actors, they, as I said, don't practice at the same time together. They practice alone and together. So we analyze this motion. This motion is nearly, I think, 45 seconds. So from I think 11 to 13, he sat down, and that part is removed. So this is the top view of the COM and GMP. So GMP or maybe COP, they are the same. So the blue line is the path of the COM, and the black thinner line is the motion of the center of pressure or GMP. And of course, COM is not straight but quite smooth. And of course, the GMP is fluctuating a bit, but as you can see, this is 20 centimeter, this is 20 centimeter. So this maximum deviation is less than 10 centimeter, something like this. So maybe, but this part is because the COM trajectory has a curvature in this way. So GMP must deviate in this way. So this is the profile of COM velocity. Actually, we only received these data very recently, so there is no much deep analysis, but we have just measured. So this is from 13 to 20, and this motion is something like that. He moves, I think, this way. So making this circular motion, again, this circular motion is quite smooth and nice circle. And circular motion, of course, need to have GMP deviated outward. So this is the GMP trajectory. But still, the fluctuation is quite well controlled. Maybe he's also controlling the hand with the fan sensu. So because of that, there are some fluctuations. This is the COM velocity. So, of course, COM velocity changes, but not much fluctuation, and there are some controlled velocity. This is again from 20 to 29. In this case, the COM and GMP moves like this, quite smooth, and deviation is well controlled, I think. This is COM velocity. This is for 34 to 40. It's very short. And it's a combination of almost straight path. The COM is a little fluctuating because he's controlling the arm motion. Well, for the overall motions from 0 to 45, this is the head pitch angle. And this is 0, this is 5, this is 10. So maybe around 10 degrees. he's supposed to control 0, but probably this is the initial error of our measurement. We haven't well calibrated. So, of course, from 11 to 13, he's sitting down, so there are a large head movement. But other than that, head movement is, as far as I can observe from here, it's very straightforward, but maybe fluctuating from plus minus 5 degrees. And this is the shoulder roll angle. Shoulder roll angle means this movement. So he's controlling the shoulder angle except for this part. He's moving the arm here a lot. So this is quite clear. This is the distance between shoulder and the hand. The distance between shoulder and hand is almost fixed. That means elbow angle is fixed. So his motion is always like this. By the way, this kind of motion is, as far as I learned from the Wikipedia, it has some relationship with the martial art. That is explained, but I don't know the truth. So this is the neck marker Z position. That means this is a measurement of the head movement. As a marker, top marker in the neck, at the neck is attached. So this is the almost equal to the head movement. So this is 10 centimeters. So head movement is within, I guess, plus minus 5 centimeters. Well, our preliminary observation is very simple: head stability by pelvis control, and he's putting his own the constraint, such as the keeping elbow joint angle constant, or controlling the pitch angle of the head and the height of the head. These are the control, I think, parameters for the performance. And the movement is quite precise. And let me go to the measurement of ram byoshi. So if you had the chance to join the party in Japan, you might have joined the clapping hand once, right? So when the party ends, people gather together and try to clap hand at the same time. And people say, yo. It's something like this. So some synchronization is somehow controlled. And of course, the actor cannot see the musicians. Of course, before he hit the hand drum, he said something. He makes a sound, so he can observe it. But the musicians also said that there is some implicit way to synchronize. And they said that is the komi. It's hard to explain. Komi is like stopping the breath, or keeping the energy inside the body, something like that. So that's the way they said. Okay, this is the COM movement, and also GMP movement, COP movement. Well, this is only 2 centimeters, so the motion is quite limited. And I want to show this one. This is very surprising to me. This was very surprising to me. So the bottom line is the the component of the contact force from the force plate. And this is this purple arrow showing the contact force measured from the force plate on the floor. And I was very curious what's going on here and here, because the contact force became almost zero here and here. What's happening? So it's my probably the speculation and observation. You see? So, he's standing like this, right? And he doesn't want to control the COM laterally because he wants to minimize the motion. But if I raise my left leg, I have to move my COM to the right-hand side. So to avoid this, he's almost jumping, right? This is the first jump. The second jump, when he hit the floor, this is the very important instance to make the sound on the floor. But before he hit, again, if he hit this way, he have to move the COM in the lateral way. To avoid that, he jumps again, right? So for making one step, he jumps twice to control ZMP. Of course, he doesn't know. He's not really jumping. He's almost moving like this. So this is some interesting discovery for us. And he was not recognizing by himself. Well, the last one we added is that some skill of ZMP control we can explain from humanoid control point of view. And to avoid the COM motion, he's making jumping twice for making one step. Okay, the last part is the improvisation. This is like jam session. And of course, we have no idea. I mean, there are a lot of possible analysis. But of course, we cannot, we cannot reach the mystery of the jam session or mystery of clapping one time among many people. And the bottom circles are showing his muscle movement of the lower limbs. And top three are the sound of voice and sound of musicians. So we are trying to develop some dynamical system to reproduce this kind of interactions. There should be some dynamical interpretation, and I'm expecting to find some dynamic attractor or nonlinear stuff that attract the performance of all the players. So this is a big score we measured. We have more score, but this is part of it. So small drum, voice, small drum, taps, even the musician, they have the 4 EMG sensors. So we are measuring the EMG of lower limb of musicians. And of course, this is the left rectus femoris of the performer, left biceps femoris of performer, left tibialis anterior of the performer. This is the gastrocnemius of the performer. Anyway, we have all of these data. The question is, how can we reach the mechanism that for people or many people can come and make the single synchronized performance and enjoy. I don't know how to model and how to explain this. So this is why I'm trying to explain to nice mathematicians and neuroscientists who can help me. Okay, so again, as I said, there is a synchronization, and I think there should be some kind of explanation from the point of view of the attractors. And of course, we want to know the role of neural dynamics, and of course, the muscle properties, the dynamics is also should be involved. And I think that is the very fundamental skill of the human communication. And as yesterday, the Professor Alain Betuz was saying about Ma is the time in between. It is very important sense. So I don't know how to explain this and how to reach this level, but there should be some model and information. And of course, to establish very comfortable communication between robot and human, there should be a respect on the human dynamical systems. And these are probably the key part of that dynamical systems. This is the case of Dojoji, Rambyoshi. Very simple, only this much, but okay. So, so far, what we have observed is very simple. By straightforward measurement, we can look at the very unique control of pelvis, and in order to simplify the motion, and the performer is setting some constraint, and that is probably very obvious from analysis. And precision movement, we don't have very clear data yet, but we have to compare with other performers or maybe our student. But moving COM or GMP within 5 centimeters is quite precise control. And we found the unique skill of GMP control. He jumps twice for making one step. That is, I think it's very interesting findings. And the mystery is that we want to have some model to explain the synchronization between actor and musicians. And we don't know how to do this. And of course, we have more technology, and we want to use most of our technology to explain these kind of the real problems. And my colleague developed the automatic segmentation system, and we want to segment the whole dance performance and cluster those data. And the question is if we can compare the clusters of no players and clusters of kabuki players, and they explain if no player has less or minimum movement from those segmentation point of view. And of course, the investigation of the simplicity of expression, this should be done, but probably straightforward. And the last one is it's my speculation, but when we look at the actor or actress, they have nice body movement, and we can easily understand what they want to express. I think the essence is probably the sharpness of the movement, and by looking at the cluster data and comparing the maybe other performance, or comparing between different performers and between performers and normal people, we may be able to compare the sharpness of the movement. And that is probably the skill of communications. Well, the acknowledgement goes to the no players and musicians and our staff and students who have this analysis, and of course many associates who helped us in our lab. Okay, thank you very much.
Fascinating presentation. One thing I'm not quite clear on, when you reconstructed the muscle force, I understood that you found a minimum norm solution to match the joint torques, correct?
Yes.
So did you also see any evidence in the EMG of simultaneous activation of opposing muscles?
Maybe I forgot to explain. So in the measurement of the actors, we used the 16 EMG wireless detectors. And we use those major muscle activities as a reference signal to optimize whole muscle activities. So we partially use the EMG data for estimating the muscle activities.
So did you see simultaneous activation of opposing muscles?
Yes, yes.
Interesting.
We can, yes. And actually, I have slide, but I don't have time to explain. But when we analyze the top athlete, it is clear that they avoid co-contractions. It's very clear.
So it almost looks like these dancers are trying to move like robots, which, when they started this, there were no robots around, but, they're slow and precise, and there's no object manipulation. It's all flat ground. So it looks like if you want to replicate that, it's a lot easier than doing something like dynamic locomotion or robot manipulation or all the other things that we're trying to do.
But our humanoid robot, when it works, he walks like this, right?
That's because you're using ZMP. If you use something else, it won't.
No, probably it's hard to. Of course, the performer motion is simple because by using redundancies, he pretends to make the simple motions, which is not possible with a smaller number of degrees of freedom, I think.
A question related to the head stabilization. You say that the control of the pelvis has for objective to stabilize the head. If this is the case, that means that the system constituted by the spine and the head is a rigid body. Okay, then that means that the neck and the muscle of the neck just maintain this rigidity. That would mean that during all this motion, the activity of the muscle necks should be constant.
I see.
Okay, and it's possible to check that because it's strange, because the stabilization, the neck may play a role for the stabilization of the neck. But if you are right by saying that this is the motion of the pelvis that stabilizes the neck, then in that case there is no activation, or there is a constant activation of the muscles.
So I have to ask my student if we can put EMG on the neck. Yeah, maybe. But we have many muscles here, and if we attach the EMG, that measure the many information, not single muscle. Well, we can solve the problem, but it's quite probably complicated. but we can do something.
Any other question? So let's thank the speaker again. So the next